Okay, having seen the structural and condensed formula for the alkynes, let us proceed to the next homologous series, which is alkanols. We shall be looking at alkanols. Now, what are alkanols? When we talk about alkanols, we make reference to that homologous family that are also referred to as alcohols. So we either say alkanols or alcohols. The first member of this group is called methanol with the formula CH3OH. Other members in that family are ethanol, propanol, butanol, pentanol, etc. So we can see that the naming of these homologous families just follow a regular pattern. First members, families that have first members begins with met. The second members are et, third member is prop, fourth member is but, fifth member is pent, and it continues on and on. Hex, hept, oct, nun, deca. Just like we have the knowledge from our mathematics when we talk about polygons. We have triangles, we have hexagons, polygons, we have heptagons, we have octagons. That is just how these compounds are named. So the first member in alkanols is methanol, and generally alkanols are characterized with the possession of OH. They are characterized with the possession of OH. OH is the hydroxyl functional group. We are later going to talk about what we mean by the term functional groups. So, any group of organic or hydrocarbon compounds that have OH attached to them, such organic or hydrocarbon compounds are called alkanols, because that is what determines their property, their unique chemical property, OH. Their names are derived by replacing the E in alkanes with ol. So the last E letter in alkanes, when it is being replaced with ol, we derive the name for any alkanol family. Alkanols have a general molecular formula of CnH2n plus 1 OH, which can also be written as ROH. So it implies that CnH2n plus 1 is equal to R. R in chemistry is referred to as alkyl group. It is an alkyl group because it was initially an alkane that has lost one hydrogen atom, and that is why we have it as an alkyl. And we have talked about alkyl before now. The value for N in that general molecular formula is greater or equal to 1. As we have said before, alkanols are also called alcohols. So let us take a look at the members of this family of homologous series. Let's take a look at the members of the family of alkanols. The first member, as we have said, is methanol with the formula CH3OH. We have ethanol, propanol, butanol, pentanol, hexanol, heptanol. So when we look at the molecular formula of these compounds, we observe that each successive member differs from the previous member by CH2. So you can see in methanol we have CH3OH. If I'm to add CH2 to CH3, I'm going to get C2H5. The OH seems to just be a constant addition. OH, OH, OH attached to all of them. But the alkyl part of it, which is the CH3, C2H5, C3H7, is what is not constant. But OH seems to be constant for all of them. So let's take a look at one more time how to pen down the molecular formula of this homologous family of alkanols. So let us proceed just as we've done before. Let us now take a look at that for alkanols. So when we talk about alkanols, we say they have the general molecular formula of CnH2n plus 1 OH. So if I am to write out the molecular formula of the first member, we are told that N is greater or equal to 1. So it means that N begins from 1 and above. So first member, which is going to be 1, we have C bracket 1, H 2 into 1 plus 1, and OH, which is a constant parameter. So this is going to be C times 1 is C, H, 2 times 1 is 2, plus 1 is 3, OH. So we can see we have our formula, and this is called met because it has one carbon atom. This is methanol, as we can see. Methanol. This is methanol. Okay. Having seen that, methanol. Okay, I have methane written there. We are talking about methanol. Methanol. So this is methanol. Now let's look at the second member of that family, which is number 2. So we'll place C bracket 2, H 2 into 2 plus 1 OH. This is going to give us C2H. 2 times 2 is 4. 4 plus 1 is 5 OH. And this is our ethanol. Ethanol. This is ethanol. So as you can see, we said when the E in ethane is replaced with O, it's being replaced with O. When E in ethane is replaced with O, it gives us the alkanol family. So that is how we can get the molecular formula for these compounds. Having seen that, let us look at how to get their structural and condensed formula. The structural and condensed formulae. Let's proceed. So, having seen that, we shall now look at the structural and condensed formula for these compounds. So we have our alkanol, and this is molecular formula. Here we have our structural formula, and we have our condensed formula. So the first member is methanol. 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 And methanol is CH3OH. What will be the structural formula? The structural formula for the compound is going to be COH, and then we have the 3 hydrogens attached to this. This is the structural formula. And the condensed formula is quite similar to the molecular formula CH3OH. This is from methanol. Let's take a look at the second, ethanol. Ethanol is C2H5OH. So the structural formula is going to be 2 carbon atoms with OH, and now we have 5 hydrogens attached to these 2 carbon atoms. And how are they distributed? Because alkanols are not unsaturated, they are saturated compounds. The carbon atoms will have single bonds between them. So since that is so, it implies that this second carbon atom that is already attached to OH is having 2 bonds already, so it will need 2 more hydrogens to make it 4 bonds, since carbon atoms must always have 4 bonds. And the first carbon atom will take the remainder, and this is the structural formula for ethanol. The condensed formula, therefore, will be CH3 CH2OH. This is the condensed formula for ethanol. Let's look at propanol. Propanol. Propanol is C3H7OH. So we have 3 carbon atoms. They are going to be attached to OH, and they have single bonds between them because it is not an unsaturated hydrocarbon. They are saturated hydrocarbons. Since they are saturated hydrocarbons, we have the last C by the right hand side already attached to OH, and is also attached to the middle carbon atom. So it means it has 2 bonds already, and it will be needing 2 more hydrogen atoms. 2 more hydrogen atoms. And that is what we have there. So, having seen that, the middle carbon atom also will be needing 2 hydrogens, and the last we need the remainder hydrogens. So this is the structural formula for propanol. And what will be the condensed formula? The condensed formula will be CH3 CH2 CH2OH. This is the condensed formula for propanol. So we can go on and on to check for the structural condensed formula for butanol, pentanol, hexanol, heptanol, etc.